guys, Ssauce here. What are collisions?
A collision is defined as an instance of one moving object or person striking violently against another. The first instance of a collision was in 1984 when Anne-Marie Wakefield ran her 20-wheeler into Senor Garcia's red sedan. Let's take a closer look as to what happened. At this intersection, the truck driver claims he had a flashing yellow light, while the car driver had a flashing red light. Neither driver claims responsibility for the accident. The car driver, Mr. Garcia, claims to have made a full stop at the light before entering the intersection, that Miss Wakefield did not slow down prior to the collision, while the truck driver, Miss Wakefield, claims to have been braking before the collision, that Mr. Garcia did not stop at the flashing red light. Now more about the crash. The police department determined that the force required to drag a 130 Newton car tire across the pavement at a constant velocity is 100 newtons. Specifications from the truck's manufacturer claim that, for technical reasons, the effective coefficient of friction for truck tires is only 70% that of car tires. After the collision, the truck and car skidded at angles of 7 degrees above the horizontal for the truck and 33 degrees above the horizontal for the car. The car skidded a distance of 8.2 meters before stopping, while the truck skidded 11 meters before stopping. The weight of this car was 13,600 newtons, and the weight of the truck was a massive 69,700 newtons. The pre-crash angle between the velocities of the truck and car was a sweet 90 degrees. Now the truck driver claims to have been braking in anticipation of a collision, traveling only 6.7 meters per second at the moment of impact, while police measurements show that the distance for the car from the traffic light to the collision point was 13 meters. Now we got in touch with the Ford Motor Corporation, and they indicate that the maximum acceleration of a comfortably loaded Ford Escort is about 3 meters per second squared. Now the question at hand is, who's at fault?
Hey guys, it's John Jin Liang, John Jun from Ssauce. So, what Mr. Liang Jin Jun will talk about today is the initial velocity of the car and how we managed to find it. In order to find this, we want to find the friction coefficient for the car. And to do this, we divide the friction force by the normal force. So you get 100 divided by 100, but wait, there's a 30. So you get the 0.769 static coefficient. For the truck, it said that it was 70% of the 0.769, so we found it to be 0.539. Got it? Okay, so now that we have found the coefficient for friction for the car, we can find the force of friction. And so we multiply. Hey, look, a new piece of information was just teleported by the god of the... But this new information, we can see that we are finding the force of friction by multiplying the normal force, see that, by the friction coefficient. And so we find the force of friction right here, this one right, this little guy right here, is actually 10,458.4 newtons. Remember, units are very, very important. So with this information that we have just obtained, we will find the acceleration by plugging all these newly gained information into the F equals ma. Reminder that, guys, is the Newton's second law. I'm very smart. And so to find that, we plug it in and we get the acceleration, which amounts to 7.536 meters per second squared. Remember, units are very important. And so we find this kinematics equation. V squared equals VO2 plus 2A delta x. And we know that the final velocity is 0. And so we plug in all the other values and we get the value of initial velocity to 11.117 meters per second.
It's me again. Let's go to the truck calculations now. So the coefficient of friction over here will stay the same as my partner John Jin had described before, because he actually told the coefficient of friction for the truck, which is right here, 70% of that of the car, and sorry, my voice got a little high. Okay, back to normal. So, over here we have the coefficient of friction, and we need to find to this equation, which eventually comes to our final or initial velocity as 10.755 meters per second. And here's a diagram right here.
Well, component vectors. So we need to first find the component vectors of the velocities of the car and truck in order to calculate the velocity of the car and truck before the collision. So to calculate the y velocity of the car, we need to first take its velocity right after it collided, and then we use sine of 33, which is the angle that the car veered off in, and we multiply that by the final velocity, and then we get a velocity y of 6.055 meters per second. And in order to calculate the velocity in the x component, we multiply cosine of 33 degrees by the velocity, which is 11.117 meters per second, and we get the final velocity of x equals 9.324 meters per second. Now, to find the x and y velocity of the truck, yeah, 10.675 meters per second, and that's the x component of its velocity. And we do that, and then we will have momentum. Look at the momentum calculations. So we have to calculate the momentum, and to figure out, we're using momentum calculation to figure out the initial velocity, the velocity of the truck before the collision, and the velocity of the truck, or the velocity of the car before the collision. Since the car moves up and the truck moves to the left, we can say that the car moved at a 90-degree angle. The calculations for momentum is P equals mv. To solve for the unknowns here and here, we need to continue our momentum equation. So using what we had before, we can add together the x component of the car and the y component of the car before the collision, and then x and y component of the car after the collision. And then once we can solve for the velocity of y before to get 16.379 meters per second. Again, in this area, we will calculate the final velocity, which is what we have here. We had to find our initial velocity 2 times the specified acceleration for the car, and it's the distance it travels. So we can get the initial velocity of the car to be 1.741 meters per second.
Insurance companies rarely play fair and hand over a fair award. They must be hammered and hammered before they see the light.
Back from our commercial break, and we see that the car that Mr. Garcia was driving did not fully stop. What a shame. He was so close to stopping too. And Miss Wakefield, you did not slow down, man. So, got the Miss Wakefield, the truck driver. Girl, you did not slow down. So, in the end, I would say they were both wrong. But who was more wrong? Now that is the true question.